So this is problem number 20 from homework 3. The problem says 2 loudspeakers in a 20 Celsius room emit 686 Hertz sound waves along the x-axis. A. If the speakers are in phase, what is the smallest distance between the speaker for which the interference of the sound waves is perfectly destructive? From this, we can draw this drawing of a perfectly destructive in phase of 2 speakers. We have given our frequency of 686 Hertz. Our velocity of sound at 20 degrees Celsius is 343 meters per second. And then we also know that velocity equals wavelength times frequency. And from this we can solve for wavelength because we're going to need it later on in the problem. So wavelength equals velocity over frequency. So in this problem we know that the speakers are in phase, meaning that the phase difference, delta phi, can equal 0 rad. And for this problem too, we also know that it's a perfectly destructive interference. From this we can use the formula delta phi equals 2 pi delta x over lambda plus phi naught equals 2 m plus 1/2 pi. This is for perfectly destructive. And in this case, m can equal 0, 1, 2, 3, and etc. For this problem, we're going to use m equals 0 for the smallest distance. And this is going to give us 2 pi delta x over lambda plus phi naught equals pi. So now we're looking for delta x, which is our smallest distance. From this, we have to isolate delta x. By doing that, we have to divide by 2 pi on both sides. That will leave us with delta x over lambda plus phi naught equals 1/2. From this, we know that the phi naught is 0, so we can just mark it off. That will leave us with delta x over lambda equals 1/2. Now we can isolate x, multiply by lambda on both sides. From this, we also know that lambda equals velocity over frequency, which we are given, and we can just plug in to solve for x. So x equals 1/2 velocity, which is 343 meters per second, over frequency, which is 686 Hertz. That would equal 25 centimeters for our delta x. For the second part B, if the speakers are out of phase, what is the smallest distance between the speaker for which the interference of the sound wave is maximum constructive interference? For this one, we have drawn this image which shows maximum constructive interference. From this, because the speakers are out of phase, we can conclude that delta phi naught equals pi rad. Also, for constructive interference, we can use the formula delta phi equals 2 pi delta x over lambda plus phi naught equals 2 m pi. In this case, m can equal 0, 1, 2, 3, etc. For this instance, we're also going to use m equals 0 for the smallest distance as we did in part A. So we're going to use m equals 0 for for the smallest distance. So from that, we can use this formula to solve for x again. So we're going to use 2 pi delta x over lambda plus pi, because phi naught is pi, as we stated above, equals 0. Now we solve for x. First thing we do is we subtract pi from both sides. We are left off with 2 pi delta x over lambda equals negative pi. And again, we divide by 2 pi on both sides. That would give us delta x over lambda equals negative 1/2. From this, we can solve for x again by multiplying by lambda on both sides. And again, lambda is also the same as velocity over frequency as stated above. So we can just substitute what we're given over here. So delta x equals negative 1/2 times velocity, which is 343 meters per second, over frequency, which is 686 hertz. That would give us a total of negative 25 centimeters or 25 centimeters.